Hello dear children. Today we'll be dealing with algebraic identities. Already algebraic identities you have learned in class 8, and also we have learned in the first chapter also we have used the identities. There we did not say algebraic identities. The identities we have related to real numbers. Now here we'll be dealing with algebraic identities. In class 8 you have learned using the variable a and b. But now we go to variables like x, y and z. So hereafter when you are using identities we will be using the variables x, y, z, etc. Okay, we are not using a and b. So same first 4 identities I think you have learned in class 8. It is just a revision with a different variable. The first 4 identities are same as what you have learned in class 8, but there you have used a and b. So we'll just quickly go through the identities. The first identity is x plus y the whole square. X plus y the whole square is equal to x square plus 2xy plus y square. So what is the first identity? X plus y the whole square equals x square plus 2xy plus y square. Now second identity is just the reverse of this, that is x minus y the whole square. X minus y the whole square equals x square minus 2xy plus y square. Now third identity is x plus y into x minus y. This we have used for rationalizing. Very often we have used it, isn't it? But there we have taken it as a and b. So x plus y into x minus y is equal to x square minus y square. Fourth identity is x plus a into x plus b. Here x is same, only a and b are different. X plus a into x plus b equals x square plus a plus b the whole into x plus ab. And the fifth identity is a new one for you. The identity is x plus y plus z the whole square. Here 3 variables are there. Square of that is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. See the last terms here, it is cyclic. xy, yz, zx. It's going in a cyclic order. So this identity, please learn it properly. All the other 4 you have already learned, so you may be knowing those identities. The fifth one is x plus y plus z the whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. These are the 5 identities which are in relation to squares. Identities related to squares. So learn these identities. Now we'll be learning how to use these identities to solve problems, or applications of these identities we'll be looking into. One by one we will take. Okay, suppose you are having a question like this. See here, x plus 4 into x plus 5. Now you will be looking into these identities and find out which identity can be used here. Now see this one. Here the first terms of both these are the same, x itself. What is the difference? The second terms are different. So which identity among this can we use? We can use identity 4. So using identity 4, what is our x? Our x is x itself. What is our a? Our a is 4. Our b is 5. So using this identity, this will be equal to what? X plus A into X plus B will be X square plus A plus B into X. What is our A here? 4 and our B is 5. So this will be 4 plus 5 into X plus AB, product of A and B. A is 4 into B 5. So what is this? X square plus 4 plus 5 is 9x plus 4 into 5 is 20. Is it clear? We have used the identity. Which identity did we use? The fourth identity. Is it clear? Now another one question. Suppose it is look at this question. 2x plus 3 into 2x minus 3. Now look into these identities and find out which identity we can use. Now this is of which form? Just look into the identities and tell. 2x, 2x, both are same. The only difference is in the second terms. Here it is plus 3, here it is minus 3. So which identity can we use? We can use the third identity. What is the third identity? X plus y into x minus y equals x square minus y square. So what is our x here? Our x here is 2x and y is 3. So using the identity x plus y into x minus y is equal to x square minus y square. 2x plus 3 into 2x minus 3 can be written as 2x the whole square. It is not x alone squared because our x here is 2x. So 2x the whole square minus 3 square. Now 2x the whole square will be 2 square and x square multiplied. So you will be getting it as 4x square minus 3 square is 9. So this is 4x square minus 9, the simplified form using the identity. Now sometimes you may get a question like evaluating. Suppose you are asked to find like this. 102 into 105. You are asked to evaluate without multiplying directly. You are not going to multiply 102 with 105 and then finding the answer. You are going to use the identity what we have learned and then find the product of this. 102 into 105. Now how you are going to do this? Now here we will be splitting this 102 and 105 as 102 can be written as 100 plus 2 and 105 can be written as 100 plus 5. So this will be 100 plus 2 into 100 plus 5. Now this is of which form? Which identity form? It will be of identity 4. X plus A into X plus B. Why? Because here you are having the first term same 100. Only the second terms are different 2 and 5. So applying the fourth identity. What is fourth identity? X plus A into X plus B equals X square plus A plus B into X plus AB. So let us substitute. Here our X is 100, A is 2, B is 5. So X square, that will be 100 square plus A plus B, 2 plus 5 into X. X is 100 plus A into B, 2 into 5. So 100 square will be 10,000 plus 2 plus 5 is 7. 7 into 100 is 700 plus 2 into 5 is 10. So when you add this 10,000 plus 700 plus 10 will be 10,710. So without sitting and multiplying directly, we have found out using the identity. Which identity did we use there? The fourth identity. Clear? One more example I give you. Suppose it is, say, 103 into 97. 103 into 97. Now how will you do this? See, we cannot use this here. Why? Because here it is 100 plus 3, the other one will be 90 plus 7. So are the first terms the same? No. So there, that identity we cannot use. Then how we can write? Now we will be writing 103 as 100 plus 3 and 97 you will write it as 100 minus 3. So this is a which form now? A plus B in x plus y into x minus y. This is a which form? The identity 3. X plus y into x minus y, where our x is 100 and y is 3. So what is identity? X square minus y square. So this will be 100 square minus 3 square, or this is 10,000 minus 9. This will be equal to 9991. Now we'll use another one question, one more example we'll do. Say suppose you are taking 2x plus 4y plus 3z the whole square. 2x plus 4y plus 3z the whole square. Which identity can we use here? You are asked to expand this. Expand using the identity. Which identity? You will be taking the identity 5, where our x is now 2x, y is 4y and z is 3z. So applying the identity, how you will get it as? This will be equal to x square. X square here is 2x. So 2x the whole square plus y is 4y. So 4y the whole square plus z is 3z. So 3z the whole square plus 2xy. 2 into x is 2x and y is 4y plus 2yz. 2 into y is 4y, z is 3z plus 2 into zx. Z is 3z into 2x. Now you will expand. 2x the whole square will be equal to what? 4x square plus 4y the whole square is 16y square plus 3z the whole square is 9z square plus 2 into 2x into 4y. So 2 into 2, 4, 4 into 4, 16 into x into y plus 2 into 4y into 3z. 2 into 4, 8, 8 into 3, 24. So 24yz plus 2 into 3z into 2x. 2 into 3, 6 into 2, 12 plus 12zx. This is the expanded form for the given question. Which identity did we use? We have taken identity number 5. So understood how to expand and evaluate using the identities. Now sometimes you may get a question like this for factorizing. 9x square plus 6xy plus y square. You have to factorize using any of these identities. Factorizing means finding the factors. Write it as product of the factors. Now here when you get such questions, you look clearly into the expression. Look at the first and last term. See whether it is written as a perfect square. The first and the last term. Look at that. Is it written as a perfect square? 9x square. Is it a perfect square? Yes, it is a perfect square. Which square? 3x the whole square will give you 9x square. So you are going to rewrite this. This can be written as, instead of 9x square, you will be writing it as 3x the whole square. And the last one I am going to write, this is y square. Y square is actually 1y the whole square. It is also a perfect square. So 1y the whole square. Now the middle term, can't we split it and write? Of course, we will split this and write it as 2 into 3x into y. 6xy can be written as 2 into 3x into y. Now look at this expression, what you have got here. Does it resemble to any of the right hand side of the identities you have learned? Just have a look. Yes, this corresponds to what? The first identity's right hand side. X square. X square here. What is our x? This is 3x. 3x the whole square. Plus 2xy plus y square. Y here is 1y. 1y the whole square. So we can write this entire expression as, what is the left hand side corresponding? X plus y the whole square. What is our x here? 3x. And what is our y here? It is 1y only, but we write it as y only. So 3x plus y the whole square. This is not the factorized form. Factorized means you have to write it as the factors, product of the factors. So squaring means what? Multiplying with the same number 2 times, isn't it? So this you can write it as 3x plus y into 3x plus y. So this is the factorized form of the given expression. So have you understood? So if you're getting questions like this, what you will look into? Whether the first and last terms are or can be written as perfect squares. If you get that as perfect square, okay, then you will get into, yes, either first or second identity can be used. Suppose the term here was a negative term. The second term was a negative term. Then which identity you will be using? You will be using the second identity. Is it clear? So think in that way and then do the factorization. Now one more factorization we will do. You got a question here. Factorize 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz. Now in this case, 2 things you have to keep in mind. First you will be seeing whether the first 3 terms is written as a perfect square or can be written as a perfect square. First 3 terms. Then you will see the sign of the next 3 terms. That is very important. You have to look into the sign of the next 3 terms. Because you accordingly, you will have to change the sign of x, y or z depending upon in which all terms you are getting a negative sign. Now since here the 5th term is a negative, 5th and 6th term is a negative term, which means you will have to find out what variable is common there. Which is the variable that is common there? Z. If you have one negative term only, you will be getting this as negative because positive into negative is negative. So one of the terms in that, what you are going to multiply will be a negative term. So you are going to find out which is that negative term. So for that, what you are saying, which of the variable is common here? Which is common? Z is common. That means Z, whatever value you are going to put for that Z will be a negative one. Now you will be thinking, there it is negative, okay, but here if I am taking Z as negative, it is not negative here. Why isn't this negative? Because when you square a negative number, it becomes positive. So before start doing, you will be first analyzing the given expression. First thing what you will see, whether the first 3 terms can be written as perfect squares. Then you will see the next 3 terms and find which all cases there is a negative sign, so that we can find out which variable is a negative one. So here, since the 5th and 6th are negative, the variable that is common there is Z. So the Z term will be negative. Supposing these 2 were negative. These 2 were negative. The 4th and the 6th. In that case, which is common there? X is common. So the x term will be negative. Is it clear? So now let us try to write this. This 4x square, is it a perfect square? Yes, it can be written as 2x the whole square plus 9y square. 9y square can be written as 3y the whole square plus 16z square can be written as 4z square. But here we have found out the z term should be a negative term. So we'll be taking it as minus 4z the whole square. Is it clear? Why we have taken this minus 4z? Yes. Plus. Now by this time you would have got an idea. This will be which identity? So many terms like this. This will be which identity? This will correspond to fifth identity. So the remaining you can write it over here. This will be 2 into 2x into 3y plus, minus, or you can write plus 2 into 3y into minus 4z plus 2 into 2x into minus 4z. And you write like this, because here it will be 2 into 3 into minus 4, 3 into 2, 6 into 4, minus 24 yz, minus 24 yz. Here it is 2 into 2, 4 into minus 4, minus 16 xz. So this is of which identity? Fifth identity. The right hand side of fifth identity is what is shown here. So you will be writing the left hand side. What is the left hand side of that identity? X plus y plus z the whole square. So what is our x here? X is 2x, our y is 3y, and our z is minus 4z. So minus 4z the whole square. Is this a factorized form? No. So we are writing it as 2x plus 3y minus 4z into 2x plus 3y minus 4z. This is the factorized form of this given expression. Is it clear? So whenever you get questions for factorizing, you just clearly look into the expression. How many terms are there? If only 3 terms are there, this will correspond to which one? Our first or second identity only. There also, how will you find whether it is first or second? If the second term is positive, first identity. If second term is negative, second identity. Then what factorization you can get? You'll be getting this one. Fifth identity, using fifth identity. There also, what you will look? The first 3 terms, if it can be written as a perfect square. Then the remaining 3 terms, you will see where you are getting a negative sign. There, which is a variable which is common. So is it clear how to do the factorization? Okay, thank you children.